In this lecture we find out the area of the green shape using two different methods. In the drawing we have a quarter circle. AOB is a quarter circle. Inside this quarter circle we have the green quadrilateral AODC, and our mission is to find out the area of the green quadrilateral AODC. In addition, we know that side CT of the quadrilateral equals to 7 units, side AC of the green quadrilateral AODC equals to 24 units, and this angle ACD equals to 90 degrees. Again, our mission is to find out the area of quadrilateral AODC. Okay, so we'll start with the first method. Because of the fact that AOB is a quarter circle, it means that this angle AOB equals to 90 degrees. Again, AOB equals to 90 degrees. And point O is the center of the circle that we can create by completing this quarter circle to a circle. Okay, so from the center of the circle, that is to say from point O, we'll go perpendicular on chord AC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the point of tendency of the perpendicular from point O and AC is P. And here we have rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. Point O is the center of this circle. From point O, we draw perpendicular OM to chord AB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. And whenever we have from the center of the circle, that is to say from point O, perpendicular OM to AB, then this angle equals to 90 degrees and this angle equals to 90 degrees, then OM also will bisect chord AB. That is to say, AM equals to MB. Again, if OM is perpendicular to AB, then OM also bisects chord AB in the sense that AM equals to MB. Okay, so we can implement rule number 11 in our drawing. Why? Because in our drawing, point O is the center of the circle that we can create by completing this quarter circle to a circle. From the center of the circle, that is to say from point O, we draw perpendicular OP on chord AC. And therefore, according to rule number 11, perpendicular OP on chord AC also will bisect chord AC. That is to say, AP equals to PC. Again, AP equals to PC according to rule number 11. But AC in total equals to 24 units. And the perpendicular OP bisects chord AC into two halves. The first half is AP and the second half is PC, and of course AP equals to PC. So the first half is AP. If AC in total equals to 24, it means the first half will be equal to 24 over 2, that is 12. And the second half, PC, will be also equals to 12 units. So we found out actually that AP equals to PC equals to 12. And this is actually the implementation of rule number 11 in our drawing. The perpendicular OP to chord AC also bisect chord AC in the sense that AP equals to PC. AC in total equals to 24, therefore the first half of AP equals to 12 units, and the second half of AC is PC. It is also will be equal to 12 units in its length. Okay. In the next step, from point D, we will draw perpendicular on PO. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We'll define the touching point of the perpendicular from point D and PO as Q. Actually, we created here quadrilateral QPCD. Inside quadrilateral QPCD, we have 1, 2, 3 right angles. This angle equals to 90 degrees according to what is given as the question. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of this fourth angle. In total, those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. Again, in order to complete the sum of the angles inside quadrilateral PCDQ to 360 degrees, the missing angle here must be equal to 90 degrees. So inside quadrilateral QPCD, we have 4 right angles. Therefore, we relate to quadrilateral QPCD as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle PCDQ, PC must be equal to QD. But PC equals to 12, therefore QD must be also equal to 12 units in its length. Likewise, in rectangle QPCD, QP must be equal to DC. But DC is 7, therefore QP must be also equal to 7 units in its length. In the next step, we define the length of this line segment QO as X. We'll focus on the right triangle OPQ, OPD. This is the right triangle OPD. And we'll define angle QDO or OD, angle ODQ is alpha. So I'll copy the right triangle OQD in a new page, and we find out the value of tangent alpha in this right triangle OQD. Okay, so we have here the right triangle OQD. side QO equals to X according to definition. And QD equals to 12 units. Angle ODQ equals to alpha. So actually this is the right angle QDO that I copied from the original drawing. Again, QD equals to 12 units and QO equals to X. In this right angle QDO, we will get that tangents alpha equals to QO over QD. Again, tangents alpha equals to QO over QD. QO is X and QD is 12. So in conclusion, found out that tangents alpha equals to X over 12. Okay, tangents alpha equals to X over 12. So in the right triangle OQO, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. So this angle equals to 90 degrees minus alpha. We define 90 degrees minus alpha as beta. Therefore, this angle will be equal to beta. And angle AOB in total equals to 90 degrees. So 90 degrees minus angle beta must be equal to the missing angle AOP. Repeat again, the missing angle here, angle AOP, must be equal to 90 degrees minus beta. So 90 degrees minus beta, and beta is 90 degrees minus alpha, so we substitute beta here by 90 degrees minus alpha. So 90 degrees minus beta, it is actually 90 degrees minus 90 degrees minus alpha, because beta equals to 90 degrees minus alpha. We'll open the brackets here and we'll get that 90 degrees minus 90 degrees is 0. And minus times minus is plus. So in total, this expression equals to alpha. Therefore, the missing angle A or B will be equal to alpha degrees. This angle equals to alpha. So in the right triangle APO, this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, so I can write here that this angle equals to beta. I'll copy the right triangle APO in a new page and we find out the value of tangent alpha in this right triangle APO. Side AP equals to 12 units. What is the value of side PO of the right triangle APO? PO, from the law is to see that PO equals to PQ plus QO. That is to say PO equals to PQ, that is 7, plus QO, that is X. So in total PO equals to X plus 7. And this is angle alpha. So actually, this is the right triangle APO. They're coming from the original drawing. Side AP of this right triangle APO equals to 12 units. Side PO equals to X plus 7, and this is angle alpha. So in this triangle APO, we get that the tangent alpha equals to AP over PO. And tangent alpha equals to AP over PO. AP equals to 12, and PO equals to X plus 7. PO equals to X plus 7. So in total we found out actually, according to equation number 2, tangent alpha equals to 12 over X plus 7. Okay, here tangent alpha equals to 12 over X plus 7. So we have two different expressions for tangent alpha. According to this equation number 2, tangent alpha equals to 12 over X plus 7, while according to this equation number 1, tangent alpha equals to 12, X over 12. In the next step we create equation number 3. According to equation number 3, tangent alpha, according to equation number 1, must be equal to tangent alpha according to equation number 2. Okay. So here, tangent alpha according to equation number 1 is X over 12, and it must be equal to tangent alpha according to equation number 2. And tangent alpha according to equation number 2 equals to 12 or X plus 7. So actually we found out that according to equation number 3, X over 12 equals to 12 over X plus 7. Here we cross multiply this equation, and we get that according to equation number 3, X times X plus 7 equals to 12 times 12, that is 144. Here we'll open the brackets on this side of equation number 3, and we get that according to equation number 3, X times X is X squared plus 7X equals to 144. Here we subtract 144 from this equation, and finally we get that X squared plus 7X minus 144 equals to 0. So this is the quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This general formula for quadratic equations, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So in this equation for x, a, b, and c are also the coefficients of this quadratic equation. In our specific equation, in our specific quadratic equation, x squared plus 7x minus 144 equals to 0, the coefficient a equals to 1, the coefficient b equals to 7, and the coefficient c equals to minus 144. So we'll put the data inside the formula for x, and we find out the value of x in our specific quadratic equation. X squared plus 7x plus 144 equals to 0. I will remind you that x in our specific quadratic equation is the length of this 9 segment QO. So we put the data inside the formula for x, and we find out the value of the values of x. And we get that x equals to minus b. b is 7, therefore minus b is minus 7, plus minus the square root of b squared. b is 7, so b squared is 7 squared, that is 49. Minus 4 times 1 is minus 4, times c is times minus 144, because c is minus 144, over 2a. 2 times 1 is 2. So we found out that x in our specific quadratic equation equals to minus 7 plus minus square root of 49 minus 4 times minus 144 is plus 576. 576 plus 49 in total equals to 625. So inside the root we left only with 625 over 2. So actually we found out that x equals to minus 7 plus minus the square root of 625 is 25 over 2. So here we have two solutions that are possible for x. The first solution for x is x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32 over 2. Minus 32 over 2 is minus 16. So if we found out that according to the first solution for x, x equals to minus 16. But because of the fact that x is a length, and the length must be a positive number, it is impossible that x will be equal to minus 16, that is a negative number. Therefore we cancel the solution, and we left only with the second solution that is possible for x, that x equals to minus 7 plus 25 over 2. 25 minus 7 is 18, and 18 over 2 is 9. So we found out that according to the second solution, x equals to 9 units. It is to say the length of this 9 segment OP, that is x, it is equals to 9 units. And our mission is to find out the area of the green shape ACDO. So we will divide the green shape into 3 parts. We'll find out the area of each part, and then we'll add the 3 areas together, and this will be equal in total to the area of the green shape. That is the area that we are looking for. The first part of the area of the green shape will be the area of the right triangle APO. This will be A1. Again, A1 is the area of the right triangle APO. The second part of the green shape will be the area of the right triangle OQD. We define the area of the right triangle OQD is A2. And finally, the third part of the green shape will be the area of rectangle PCDQ. We define the area of rectangle PCDQ as A3. It is obvious from the drawing that the area of the green shape equals to A1 plus A2 plus A3. So I write it down. The area of the green shape in total, the area of the green shape will be equal to A1 plus A2 plus A3. In the next step, we'll find out the area of each part, and then we'll add the 3 areas together, and this will be in total the area of the green shape. That is the area that we are looking for. So again, A1 is the area of the right triangle APO. So I'll copy the right triangle APO in this new page, and we find out the area of this right triangle APO. Side AP of the right triangle APO equals to 12 units. PO equals to 7 plus x, and x is 9, so in total PO will be equal to 7 plus 9, that is 16. So actually A1 equals to the area of this right triangle APO. The area of this right triangle equals to the base, that is AP, times the height to the base, that is PO, over 2. AP equals to 12, PO equals to 16, all divided by 2. 16 over 2 is 8, and in total this expression will be equal to 8 times 12. 8 times 12 is equal to 96. In conclusion, found out that the area of A1 equals to 96 square units. That is actually the area of this right triangle APO. The next step, we find out the area of A2. A2 is the area of this right triangle OQD. So I copy the right triangle OQD in this new page, and we'll find out the area of this right triangle. Triangle OQD. OQ equals to X and X is equals to 9 and QD equals to 12 units. Okay, this is the right triangle OQD that according to the original drawing, and this is actually A2, the area of A2, that is the area of this right triangle OQD. The area of this right triangle OQD will be equal to the base of the triangle that is QO times the height to the base that is QD over 2. Okay? The base is QO, the height to the base is QD over 2. QO is 9 times QD is 12 over 2. 12 over 2 is 6, so this expression in total equals to 6 times 9. 6 times 9 is 54. So in conclusion, we found out that the area of this right triangle QOD, that is A2, equals to 54 square units. And finally, we find out the area of A3. A3, it is actually the area of this rectangle QPCD. The area of any rectangle equals to the length of the rectangle times the width of the rectangle. The length of this rectangle is PC and the width is PQ. The length PC equals to 12 units and the width is PQ, that is equals to 7 units. So in total, the area of the rectangle A3 equals to 12 times 7, that is actually 84 square units. So we found out that A3 equals to 84 square units. Okay, so A1 equals to 96, A2 equals to 54, and A3 equals to 84 square units. Again, repeat again that the area of the green shape in total is equal to A1 plus A2 plus A3. A1 equals to 96 square units plus A2 equals to 54 square units plus A3, it is equal to 84 square units. 96 plus 54, it is 150, and 150 plus 84 equals to 234 square units. So in conclusion, found out that the area of the green shape in total it is equals to 234 square units. And that is the answer to the question. The area of this green shape in total equals to 234 square units. We finished with the first method. In the next step, I will present to you how to find out the area of this green shape according to the second method. In the second method, we join points A and D together by a straight line. By joining points A and D, we created here the right triangle ACD. Side AC equals to 24 units in its length, side DC equals to 7 units in its length, according to what is given us the question. The only missing side is the side of the hypotenuse AD. So copy the right triangle ACD in a new page and we find out the length of the hypotenuse AD. We're talking about the right triangle ACD. We implement the Pythagoras theorem on this right triangle ACD in order to find out the length of the hypotenuse AD by PT's implementation for Pythagoras theorem. So actually, this is the right triangle ACD, the comments from the original domain. AC equals to 24 and CD equals to 7 units according to what is given as the question. According to the Pythagoras theorem, in this right triangle ACD, we get that AD squared, that is the square of the hypotenuse, must be equal to AC square plus DC square. And then in the right triangle, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. AD square equals to AC square plus CC square. AD square equals to AC square plus CD square. So AD square, that is the square of the hypotenuse, must be equals to AC square. AC is 24, therefore AC square is 24 squared, that is 576. Plus DC square. DC is 7, therefore DC square is 7 squared, that is 49. So in total we found out that AD square in conclusion equals to 576 plus 49. It is equals to 625. When you take a root out of this equation, finally we get that AD equals to the square root of 625, that is actually 25. So I found out that the hypotenuse AD in this right triangle ACD equals to 25 units in its length. So you can argue that the hypotenuse AD equals to 25 units in its length because of the fact that AOB is a quarter circle. It means that this angle will be always equal to 90 degrees because AOB is a quarter circle. Point O is the center of the circle that we will create by completing this quarter circle to a circle. Now we complete this quarter circle to a circle. So actually completed this quarter circle to a circle. Again, point O is the center of the circle, point A is the point of the circle itself, therefore this is exactly the definition of a radius. Therefore AO is the radius of this circle, we'll define the radius of this circle is R, therefore AO will be equal to R. In the next step, we'll extend the radius AO by straight line until it will touch the circle So this is the touching point of the extended radius AO, and the circle will define the touching point as M. Again, point O is the center of the circle, point M is the point of the circle itself, therefore OM must be also equal to the radius of this circle, that is to say it is equal to R. So AM is a chord because we extended the radius AO by a straight line, the result AM must be a straight line. AM is a chord that passes for point O, that is to say for the point of the circle. Any chord that passes for the center of the circle must be the diameter of the circle, therefore AM is the diameter of the circle. Again, because of the fact that AM is a chord that passes for point O, that is the center of the circle, any chord that passes for the center of the circle must be the diameter of the circle, therefore AM is the diameter of the circle. What is the length of AM? AM equals to R plus R, that is to R. You know that the diameter of any circle equals, it's twice as long as the radius is R, therefore the diameter must be equal to 2R. AM equals to 2R. In the next step, we'll extend side CD by a straight line until it touches the circle. The question is where the extended side CD will touch the circle. Okay, so we will assume that the extended side CD will not touch the circle exactly at point M, but at another point. For example, that the extended side CD will touch the circle at this point, point N. Therefore, we will get here that the peripheral angle ACN that is equals to 90 degrees according to what is given us the question, because this angle equals to 90 degrees, therefore the peripheral angle ACN is equal to 90 degrees doesn't rest on AM, that is the diameter of the circle, but it rests on AN, that is not the diameter of the circle. But then it will contradict rule number 5. According to rule number 5, any peripheral angle that is equals to 90 degrees must rest on the diameter of the circle. Here we have peripheral angle MAN that is equal to 90 degrees, and here this peripheral angle MAN rests on MN, that is the diameter of the circle. But here peripheral angle ACN that is also equals to 90 degrees doesn't rest on AM, that is the diameter of the circle, but it rests on chord AN that is not the diameter of the circle. And it contradicts rule number 5 because peripheral angle ACN that is equals to 90 degrees must rest on AM. That is the diameter of the circle, but here, according to our construction, peripheral angle ACN will rest on AM, that is not the diameter of the circle. So in order to avoid the contradiction to rule number 5, we must conclude that the extended side CD will touch the circle at point M and not in any other point other than point M. Okay, so here in order to avoid the contradiction to rule number 5, we must assume that the extended side CD will touch the circle at point M. So CDM is one straight line, and here we have peripheral angle ACM that is equal to 90 degrees, and indeed peripheral angle ACM obeys to rule number 5 in the sense that this peripheral angle ACM rests on AM, that is the diameter of the circle, exactly according to rule number 5. Okay. So, repeat again that CDM is one straight line because we extended side CD by a straight line, therefore the result CDM must be also a straight line. We'll focus on this side of the diameter AM. AM is a diameter, it is absolutely a straight line, so in this side of the straight line AM at point O, we have which angles we have? We have this angle plus the missing angle. In total, they must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So we have here 90 degrees plus the missing angle. In total, must be equal to 180 degrees. Therefore, the missing angle must be also equal to 90 degrees. In order to complete the sum of the angles on this side of AM at point O to 180 degrees, the missing angle here must be equal to 90 degrees. So here we have we'll prove in the next step that the right green triangle AODs can point to the white triangle ODM. So I write it down. The right green triangle AOD is congruent to the right white triangle ODM. So why the green triangle congruent to the white triangle? First of all, side AO of the green triangle equals to side OM of the white triangle. Repeat again, side AO of the green triangle equals to side OM of the white triangle. They are both the radii of the circle, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees, therefore they are equal to each other. So angle AOD, the green triangle, equals to angle MOD in the white triangle. Repeat again, angle AOD in the green triangle equals to angle MOD in the white triangle. They are both equal to 90 degrees, therefore they are equal to each other. And finally, side OD is a common side that belongs to both triangles, so OD equals to itself. It's a common side that belongs to both triangles. Repeat again. Side OD is a common side that belongs to both triangles, so we can write down that OD equals to itself. It's a common side that belongs to both triangles. So actually proved that the green triangle AOD can go into the white triangle ODM according to side angle side rule. The green triangle AOD congruent, this is the side of congruent to the white triangle OTM according to side angle side rule. That is to say, those two sides and the angle between those two sides are correspondingly congruent to those two sides and the angle between those two sides in the white triangle. Again, those two sides and the angle between those two sides in the green triangle are correspondingly congruent to those two sides and the angle between those two sides in the white triangle. Therefore, those two white triangles can go into each other according to side angle side rule. And from the fact that those two triangles can go into each other, we will derive that side AD of the green triangle is equal to side DM of the white triangle. I'll write it down, AD equals to DM. AD equals to DM according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides AD and DM must be also equal to each other. But AD equals to 25, so we can write here that AD equals to 25 units in its length, according to what we have already found out in the beginning of the solving of this problem according to the second method. And from this equation 25 equals to 8 equals to dm, we will derive that dm is also equal to 25 units in its length. Side dm also equals to 25 units in its length. This is side dm that equals to 25 units in its length. CDM is one side line because we extended the side line CD by side line. The result is CM. Therefore, CM must be also equal. It must be a side line. What is the length of the side line CM? CM equals to CD plus DM. So CM equals to CD, that is 7, plus DM, that is 25. So in total, CM equals to 7 plus 25, that is 32. AC equals to 24 units according to what is given as the equation, and AM is the diameter of this circle that is equal to 2R. So I'll copy the right triangle ACM in a new page, and we'll implement in this right triangle ACM the Pythagoras theorem in order to find out the value of R. The length of the radius of this circle, that is R. So this is the right triangle ACM that I covered from the original drawing. AC equals to 24 units according to what is given us in the question. We just right now found out that the length of side CM is 32 units and AM is the diameter of the circle that is equals to 2R. According to the Pythagoras theorem, here by PT is the progression from Pythagoras theorem. In this right triangle, we get that according to the Pythagoras theorem, AM squared, that is the square of the hypotenuse, must be equals to AC squared plus CM squared. AM is 2R, therefore AM squared is 2R squared. 2R squared is 4R squared. That is equals to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576 plus CM squared. CM is 32, therefore CM squared is 32 squared, that is 1024. In conclusion, found out that 4R squared equals to 576 plus 1024. In total, it is equals to 1600. So 4R squared equals to 1600. We divide this equation by 4. And finally, we get that R squared equals to 1600 over 4 is 400. We take a root out of this equation and we get that R equals to the square root of 400, that is 20. So the radius of this circle R, radius R of this circle equals to 20 units. In the next step, we'll implement the Pythagoras theorem on the right hand triangle AOD. So I copy the right hand triangle AOD in the new page and we find out the missing side OD by implementing the Pythagoras theorem on this right triangle AOD. The hypotenuse AD equals to 25 units and AO is the radius, that is 20 units. So actually this is the green right triangle AOD is the copy from the original drawing. By PT is the version for Pythagoras theorem. According to the Pythagoras theorem, in this right triangle AOD, AD square equals to AO square plus OD square. AD is 25, therefore AD squared is 25 squared, that is 625. And it is equals to AO squared. AO is 20, therefore AO squared is 20 squared, that is 400. Plus OD squared. OD is the missing side, so we leave it as it is. In conclusion, found out that 624 equals to 400 plus OD squared. We subtract 400 from this equation. And we get that 625 times 400 is 225 equals to OD squared. Here we take a root out of this equation and finally we get that OD equals to the square root of 225, this is 15. So the length of this, the missing side OD, it is equals to 15 units. We are looking for the area of the green shape. We divide the area of the green shape into two parts. The first part is the area of the right triangle AOD, that we define as A1, and the second part of the green shape will be the area of the right triangle ACD. We define it as A2. It is obvious that the sum of the areas of those two right triangles AOD and ACD, in total it is equal to the area of the green shape. That is to say, the area of the green shape equals to A1 plus A2. So I'll write it down. The area of the green shape equals to A1 plus A2. Again, A1 is the area of the right triangle AOD. So I'll copy the right triangle AOD here and we'll find out the area of this green right triangle. AO is the radius that is equals to 20, and we just right now found out that OD equals to 15. Again, A1 is the area of this right triangle AOD. The area of this right triangle AOD will be equal to the base of the triangle that is OD times the height to the base that is AO over 2. So OD is 15 times AO that is 20 over 2. 15 times 20 is 300, and 300 over 2 is 150. So in conclusion, found out that A1, that is the area of this right triangle AOD, equals to 150 square units. The next step we find out the value of A2, that is actually the area of the right triangle ACD. So I copy the right triangle ACD in a new page and I find out the area of this right triangle. Again, A2 is the area of this right triangle ACD. The area of this right triangle ACD will be equal to the base that is CD times the height to the base that is AC over 2. CD is 7 times AC is 24 all divided by 2. 24 over 2 is 12, so in total this expression equals to 12 times 7, that is actually 84. So we found out that A2 equals to 84 square units, that is actually the area of this right triangle ACD, and we have already found out that A1 equals to 150 square units. We know that the area of the green shape in total it is equals to A1 plus A2. Again, the green shape equals to A1 plus A2. A1 is 84 plus A2, that is 150. 84 plus 150, in total it is equals to 234. So in conclusion, found out that the area of the green shape equals to 234 square units. Okay. So in the next step, I'll summarize the lecture. We start with the first method. In this lecture, we found out the area of this green shape. In the drawing, we have a quarter circle. A or B is a quarter circle. Inside this quarter circle, we have the green quadrangle ACOD. Our mission is to find out the area of this quadrangle, the green quadrangle AOCD. In addition, we know that side CD of the quadrangle equals to 7 units in its length, and side AC of the quadrangle ACOD equals to 24 units in its length, and this angle ACD equals to 90 degrees. Okay, and in order to find out the area of this green shape, first of all, we know that A or B is a quarter circle, therefore this area must be equal to 90 degrees, and point O is the center of the circle that we can create by completing this quarter circle to a circle. So from point O, that is the center of the circle, we draw perpendicular called AC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AC as P. So here we have rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. Point O is the center of the circle. From point O we draw perpendicular OM. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. And whenever we have perpendicular from the center of the circle towards any chord, that perpendicular also will bisect the chord. That is to say, OM divides chord AB into two halves. The first half is AM and the second half is MP. The fourth AM equals to MB. We can implement rule number 11 in our drawing. Why? Because in our drawing, point O is the center of the circle that we can create by completing this quarter circle to a circle. From the center of the circle, we draw perpendicular OP. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. And according to rule number 11, the perpendicular OP also bisects chord AC. That is to say, AP equals to PC. And because of the fact that in total AC equals to 24, therefore each half will be equals to 24 over 2, that is 12. So AP equals to 12 units and PC equals to 12 units. This is actually the implementation of rule number 11 in our drawing. Again, AP equals to 12 and PC also equals to 12 according to rule number 11. And then from point O, we draw perpendicular on PO. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point D and PO is Q. So in this way we created quadrangle PC DQ. Inside this quadrangle we have 1, 2, 3 rectangles. This angle equals to 90 degrees according to what is given in the question. So we have 1, 2, 3 rectangles. The sum of 3 rectangles is 19 times 3 is 270 degrees, plus the size of this fourth angle In total, the sum of those four angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. So we found out that inside quadrilateral PCQD we have four right angles. Therefore, we can relate to quadrilateral PCDQ as a rectangle, and we also know that the opposite sides of rectangle are equal to each other. So in rectangle PCQD, PC must be equal to QD. But PC is 12, therefore QD must be also equal to 12. Likewise, in rectangle PCQD, CD must be equal to PQ. But CD is 7, therefore PQ must be also equal to 7 units. Then we defined the length of this line segment QO as X. We focused on the right angle QOD, and we defined this angle as alpha. So in the right angle QOD, this right angle, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees. That is the sum of the angles in any triangle. So this angle equals to 90 degrees minus alpha. We define 90 degrees minus alpha as beta, therefore this angle must be equal to beta. Then I copy the right triangle QOD here in a new page. This is the right triangle QOD that I copied from the original drawing. This angle equals to alpha according to our definition. QD equals to 12 units. And what is the length of PO? PO equals to PQ plus QO. That is to say, PO equals to PQ, that is 7, plus QO, that is X. So in total, PO equals to X plus 7. PO equals to X plus 7. Again, QO equals to QD equals to 12 units in its length, and QO equals to X according to our definition. And this is angle alpha, also according to our definition. So in the right triangle QOD, we get that tangent alpha equals to QO over QD. QO is X and QD is 12, so in total we found out that tangent alpha equals to X over 12. Okay. Then in the right angle QOD, this angle equals to alpha, and this angle equals to 90 degrees minus alpha, but according to our definition, 90 degrees minus alpha equals to beta, therefore this angle must be equal to beta. Then we know that angle AOB equals to 90 degrees, so 90 degrees minus beta, it is equal to the missing angle AOP. Okay, so the missing angle AOP equals to 90 degrees minus beta. 90 degrees minus beta, and beta is 90 degrees minus alpha, so we substitute beta by 90 degrees minus alpha. And we found out that 90 degrees minus 90 degrees minus alpha equals to, we open the brackets, and we found out that 90 degrees minus 90 degrees is 0, and minus times minus is plus, and minus times minus is plus, and total this expression equals to alpha. So the missing angle here, angle AOP equals to alpha. In the right angle AOP, this angle equals to alpha. This angle equals to 90 degrees, therefore the missing angle here must be equals to 90 degrees minus alpha. But 90 degrees minus alpha is beta, so we can substitute 90 degrees minus alpha here by beta. Then I copied the right angle APO in a new page, and we found out the value of tangent alpha in this right angle APO. This is the right angle APO that I copied from the original drawing. Side AP equals to 12 units. And again, PO equals to PQ plus QO. That is to say, in total, PO equals to PQ, that is 7, plus QO, that is X. So in total, PO equals to X plus 7. PO equals to X plus 7. AP equals to 12, and this is angle alpha. And this is angle alpha. So in this right triangle APO, we get that tangent alpha equals to AP over PO. Again, tangent alpha equals to AP over PO. AP is 12 and PO is X plus 7. So in total we found out actually the tangent alpha equals to 12 over X plus 7. So we have here two different expressions for tangent alpha. Tangent alpha equals to either X over 12, but according to equation number 2, tangent alpha equals to 12 over X plus 7. So we created equation number 3, and according to equation number 3, tangent alpha according to equation number 1 must be equal to tangent alpha according to equation number 2. Tangent alpha according to equation number 1 equals to X over 12, and it must be equal to tangent alpha according to equation number 2, that is equals to 12 over X plus 7. Here we cross multiply this equation and found out that X times X plus 7 equals to 12 times 12, that is 144. Here we open the brackets and found out that X times X is X squared plus 7X equals to 144. We subtracted 144 from this equation and finally found out that X squared plus 7x minus 144 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b and c are the coefficients of the quadratic equation, of the general quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to this special formula. X equals to minus b plus minus the square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, x squared plus 7x minus 144 equals to 0. The coefficient a equals to 1, the coefficient b equals to 7, and the coefficient c equals to minus 144. So we have to put the data inside this formula for x in order to find out the value of x. Remind you that x, according to our definition, x is the length of line segment QO. So here we get that x equals to minus b. b is 7, therefore minus b is minus 7, plus minus square root of b squared. b is 7, therefore b squared is 7 squared, that is 49. Minus 4 times a is 1, times c is minus 144. So inside the root we have 49 minus 4 times minus 144 is plus 576, so 576 plus 49, in total it is equals to 625. So inside the root we left only with 625 over 2a, 2a is 1, so 2a is 2. So in conclusion we found out actually that x equals to minus 7 plus minus, and the square root of 625 is 25 divided by 2. So here we have two solutions that are possible for x. The first solution for x is x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32, and minus 32 over 2 is minus 16. So we found out that x equals to minus 16. But because of the fact that x is a length, and the length must be a positive number, we cancel this solution for x that is a negative number. And we left only with the second solution that is possible for x. X equals to minus 7 plus 25 over 2. 25 minus 7 is 18, and 18 over 2 is 9. So in conclusion, we found out that x equals to 9. The length of this 97 QO, that is x, it is equal to 9 units. Then we divided the area of the green shape into 3 parts. The first part is the area of the right triangle APO. The second part is the area that we define the same one. The second part is the area of the right triangle QOD that we defined as A2. And finally, the third part is the area of the rectangle PCQD that we defined as A3. And it is obvious from the drawing that in total the area of the green shape will be equal to A1 plus A2 plus A3. Again, the area of the green shape will be equal to A1 plus A2 plus A3. A1 is the area of this right triangle APO. AP is 12 and PO is x plus 7 and x is 9, so 9 plus 7 is 16. So A1 equals to the base AP times the height to the base PO over 2. AP is 12, PO is 16, all divided by 2. 16 over 2 is 8, so in total this expression equals to 8 times 12, that is 96. So A1 equals to 96 square units. Then we found out the value of A2. A2 is the area of this right triangle QOD. QOD equals to 12 and QO is x, that is 9. So the area of this right triangle QOD, that is A2, is equals to QO, that is the base, times the height to the base, that is QD is the base, times the height to the base, that is QO over 2. So QD is 12 and QO is 9, so it is 9 times 12 over 2. 12 over 2 is 6. So in total this expression equals to 6 times 9, that is 54. In conclusion, we found out that A2 equals to 54 square units. And finally we found out the value of A3, that is actually the area of rectangle PCQD. The area of any rectangle is the length of the rectangle times the width. The length is PC, that is equals to 12 units, and the width is PQ, that is equal to 7 units. 12 times 7 is 84. So in conclusion, we found out that the area of the rectangle it is equal to A3, that is 84 square units, and the total area of the green shape, so as mentioned before, is equal to A1 plus A2 plus A3. A1 is 96, A2 is 54, and A3 is 84. 96 plus 54, it is 150, and 150 plus 84 is equal to 234 square units. So finally we found out that the area of the green shape equals to 234 square units. We finished the first method, then I presented to you how to find out the area of the green shape according to the second method. In the second method, we actually joined points A and D together by a straight line. In this way, we created the right triangle ACD, implemented the Pythagoras theorem in the right triangle ACD in order to find out the value of the hypotenuse AD. This is the right triangle ACD that the copies from the original drawing. AC equals to 24, CD equals to 7, AD is the hypotenuse that is missing. According to the Pythagoras theorem, this right triangle ACD, AD square equals to AC square plus CD square. AD square equals to AC square. AC is 24, therefore AC square is 24 squared, that is 576, plus CD square. CD is 7, therefore CD square is 7 squared, that is 49. So AD square equals to 576 plus 49, that is 625. We took order of this equation, we found out that AD equals to the square root of 625, that is 25. Okay, then we completed this quarter circle to a circle. We extended point O is the center of the circle, point A is the point of the circle itself, therefore AO is the radius of this circle that we defined as R. We extended the radius AO until it touches the circle point M. point O is the center of the circle, point M is the point of the circle itself, therefore OM is also the radius of this circle, that is equal to R. So AM is a chord that passes from the center of the circle. Any chord that passes from the center of the circle must be the diameter of the circle, therefore AM is the diameter of the circle, and it equals to R plus R, that is 2R. Then we extended side CD. The question is where the extended side D will touch the circle. We assumed that the extended side D will not touch the circle at point M, but in any other point, that is to say point N. And then found out that it is impossible. Why? Because peripheral angle ACN equals to 90 degrees, and it must rest on AM, that is the diameter of the circle, according to rule number 5. Therefore, we must conclude that the extended side CD must touch the circle at point M and not in any other point, and then we not have contradiction to rule number 5. Therefore, why? Because peripheral angle ACM is equal to 90 degrees, indeed rests on AM, that is the diameter of the circle, exactly according to rule number 5. Then this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees, according to rule number 2, that the sum of the angles on one side of a straight line is equal to 180 degrees. Then we prove that those two right angles can point to each other. AO equals to OM, they are both on the area of the circle, therefore they are equal to each other. Those two angles are both equal to 90 degrees, therefore they are equal to each other. And DO is the common side that belongs to both triangles, so DO equals to itself. So those two triangles can point to each other according to side angle sine rule. And therefore, AD must be equal to DM according to the rule that corresponding sides and congruent triangles are equal to each other. But AD equals to 25, therefore DM must be also equal to 25. So in total, CM equals to CD plus DM, that is 7 plus 25, that is 32. AC equals to 24, and AM is the diameter of the circle, that is 2R. Okay, so here I copied the right triangle ACM here. We implemented the Pythagoras theorem on the right triangle ACM. According to the Pythagoras theorem, AM square equals to AC square plus CM square. We solve this simple equation, and we get that the hypotenuse AM equals to 20 units, R equals to 20 units. Then we implemented the Pythagoras theorem on this right triangle. AO equals to R, AD equals to 25, therefore the missing side, according to the Pythagoras theorem, OD must be equal to 15 units. And the area of the green shape will be equal to the area of the right triangle AOD, that is A1, plus the area of the right triangle ACD, that is A2. So in total, the area of the green shape equals to A1 plus A2. What is the area of the right triangle AOD? This is triangle AOD. So we already found out that the missing side OD, according to the Pythagoras theorem, must be equal to 15 units. So AO equals to 20, OD equals to 15. Therefore, the area of this right triangle is 20 times 15 over 2, that is 150. So A1 equals to 150 plus A2. A2 is the area of this right triangle ADC. So I copy the right triangle ADC here. AC equals to 24, CD equals to 7. Therefore, the area of this right triangle equals to 24 times 7 over 2. 24 times 7 over 2 is 84. In total, the area of this green shape equals to A1 plus A2. A1 is the area of this right triangle AOD, that is actually equals to 150, plus A2, that is the area of the right triangle ACD, that is 84. So A1 plus A2 is 84 plus 150, that is in total equals to 234 square units. We found out that according to the second method, also the area of this green shape equals to 234 square units. Okay, thank you very much.